Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 7A assignment. Okay, first one we're going to take a look at, number 1 here. For each of the following triangles, find sine theta, cosine theta, and tan theta. So, sine theta, cosine theta, and tangent of theta. So sine, from our dear friend SOHCAHTOA, is opposite over hypotenuse from this angle. Opposite side is this here. This is the adjacent, and that's the hypotenuse, right? So opposite over hypotenuse is always across from the right angle. So opposite over hypotenuse in this case is going to be 4/5. Cosine is adjacent over hypotenuse, so that is adjacent. In fact, what you could do at the very beginning here is say, okay, this is the opposite side, this is the hypotenuse, and this side's the adjacent side. So then you can simply just go, oh, from the angle, adjacent over hypotenuse is going to be 3/5. Tangent is opposite over adjacent, 4/3. Okay? Same thing for E. Sine theta, cosine theta, and tangent theta. Okay, so long as you just have one angle that you're looking at here, you can go through and label everything that you need. If you have like theta and say beta, because sometimes I'll put a couple of different ones in there, then I would suggest probably not labeling everything, or if you do, label it with a pencil so that you can erase it later. Anyway, this side here is the, well, let's see, this over here. This is the opposite. This is the hypotenuse. And this is adjacent, right? Because adjacent means right next to, but since that's already the hypotenuse, that's got to be the adjacent. Okay. Now, problem is we don't actually know what the opposite side is here, so we're going to have to use a squared plus b squared equals c squared, right? Important part about this is that the hypotenuse always has to be the c squared, so that's 7 squared. And we can do, say, well, there's our adjacent, so let's do that, 4 squared plus the opposite side squared equals 7. And now that's not 0, that's O for opposite. Let's just do x instead, right? So 16 plus x squared equals 49. Subtract 16 from both sides, and we get x squared equals, what, 33? Square root both of those, and we get x equals, okay, that gives us 5.74 for our x value. So we can just do that one, where you know what, we could even just do 5.7 is fine. So then sine from this angle is opposite over hypotenuse. So that's going to be 5.7/7. You could even leave this as, the square root of 33 as well if you wanted, but I kind of like decimals more than I like my roots. So anyway, whichever one you prefer. Cosine of theta is adjacent over hypotenuse, so that's 4/7. And tangent is opposite over adjacent, so that's 5.7/4. Okay? All right. Moving on to number 2. Use your calculator to find correct to 3 decimal places the sine of 20 degrees. So on here you simply do, first thing, super important, in the mode, make sure that you are in degrees mode with your graphing calculator, scientific calculator, whatever you're using. Make sure you're in degrees mode. So we are in degrees, so I do second quit. You usually don't have to worry about it too much on the scientific calculator, but in graphing calculator, it usually defaults to what we call radians, and we'll talk about that a little bit next year. But anyway, now that we know we're in degrees mode, we're going to do sine of 20. Hit equals, and that gives us 0.342 to 3 decimal places equals 0.342. Okay? Just to let you know what this means, not that they're asking you, but just so you know, let's say here, like this here, let's call this, oops, this is 20 degrees, okay? And if this is a unit circle, we'll call this 1. That means that this side over here is 0.342. right? Because the sine of 20 is going to be opposite over hypotenuse. Is going to equal 0.342 over 1, which equals 0.342. Or basically, it doesn't even matter what either of these are. What it matters is that whatever this number is, and you divide it by that number, it's always going to give you the ratio of 0.342. So that gives you a ratio. So like, let's say if this was twice as long, went out here, so that this here now is actually 2, right? And then this is this here. So this would actually be twice as big. This would be 0.684. If you take 0.684 and you divide it by 2, you get 0.342 again. Anyway, moving on. Number 5, consider the right-angled isosceles triangle ABC alongside here. Explain why ABC has to equal 45 degrees. So A to B to C. So they're saying, why does this angle here have to equal 45 degrees? Well, let's see. We know that all the angles of a triangle add up to 180, right? So angle A plus angle B plus angle C has to equal 180. We know that angle C, we know that angle C is, there we go. We know that this is 90 degrees, right? And then angle A and angle B, since this is an isosceles triangle, these two angles are the same, so we know that those are going to be the same. So I'm going to do this. Angle A is going to be the same measure as angle B, so I'm going to substitute angle A and put angle B in, plus angle B. So that means 2 angle B's plus 90 have to equal 180. So we subtract 90 from both sides. 2 angle B's is going to have to equal 90 degrees. So we got to divide both sides by 2 because those two angles have to share evenly what's left over, which gives us 45 degrees. Okay. So basically, probably an easier way to say that is we know that this equals 180. We've already used 90 degrees there. So these two, angle A and angle B, have to evenly split. The remaining 90 degrees. So 90 divided by 2 gives us 45. That's probably a little bit better way to do it than this crazy formula way. Anyway, that's A. Part B, use Pythagoras' theorem to find AB. So A squared plus B squared equals C squared, right? So this here is side C. This here across from angle A is side A, and this across from angle B is side B. So we know that side A is 1, side B, is also 1, and we don't know what side C is. That's what we're going to figure out. So 1 squared is 1, plus 1 squared is 1. So C squared equals 2, so we square root that, and we get that C equals square root of 2, or C is 1.41 for our decimal. So either one of those is fine. Root 2 is a little bit more officially accurate, but this is fine, just like this. 1.41 is also good. Okay. So since we're going to check our answers using a calculator, let's do this. Let's leave that as 1.41. So hence find the sine of 45. So part C, sine 45. And we're going to do cosine 45 and tangent of 45. So sine is opposite over hypotenuse. So from, let's see, sine of, I guess it really doesn't matter either one of these because the opposites and adjacents are going to be the same. So from, say, this angle here, opposite is 1 over 1.41. Right? And then cosine is going to be adjacent. That's 1 over 1.41. And then tangent is opposite over adjacent, which is going to equal 1 over 1, which is just 1. Okay? And it says check your answers using a calculator. So if we did, say, sine of 45 gives us 0.707. Now, if we take 1 and we divide it by 1.41, guess, oh, not 11. So let's do this again. We did sine of 45, gave us 0.707, and then we wanted to figure out what is 1 divided by 1.41. Oh, I did 1.14. 1.41. There we go. And look, we get 0.709. It's the same just because we rounded it off. Okay? So those two are going to both equal 0.707. So these two are the same. And then really all we got to do, because again it's, oh, well, you know what? Let me backtrack. Let's do cosine of 45. And look, cosine 45 is also 0.707, which is 1 over 1.41. And then tangent of 45 should equal 1, and it does. Okay? Okay. One more to take a look at, number 7. Consider the right-angled triangle shown. Write expressions for all of these things here. Okay, so let's do this. I'm just going to put, I'm just going to put equal signs in here. Sine of A, so sine is opposite over hypotenuse, right? This for sure is always going to be the hypotenuse. And if this is the angle we're looking at, if we're starting from A, that's the opposite. If we're starting from angle B, then this is the opposite. So these two can interchange between opposites and adjacents depending on which angle you are choosing, but this will always be the hypotenuse. So sine of A is opposite over hypotenuse, so that's going to be A over C. Sine of B is opposite over hypotenuse, which is B over C. Cosine of A is adjacent over hypotenuse, which is B over C. Cosine of B is adjacent over hypotenuse, which is A over C. And then tangent of A is opposite over adjacent, which is A over B. And tangent of B is opposite over adjacent, which is B over A. State the relationship between A and B. Okay, so a relationship between A and B, we can write this as A is going to equal, because we know that A and B have to share the remaining 90 degrees that are left in this triangle. So A is going to equal 90 degrees minus whatever B is. Okay, or we could say that B is going to equal the 90 degrees minus whatever A is. So for example, let's say if B was 20, if B is 20, then A would have to be 90 minus 20. A would have to be 70, right? And in the same case, if A was 70, 90 minus 70 tells us that B is 20. Okay? Just to kind of give you actual numbers in there. Okay? So hence state the relationship between sine theta and cosine of 90 minus theta. Okay? So cosine of 90 minus, so we got sine of theta. So let's say, again, let's say this A is 70. Okay, so sine of 70, just to kind of show you what's going on here. So if we do sine of 70, we get 0.9396. Okay, and then if we do cosine of 90 minus theta, that's going to be 90 minus, that's going to be 90 minus 70 in our case here, which is going to be cosine of 20 degrees, right? So then if we do cosine of 20 degrees, guess what we get? The exact same number. Okay? So sine and cosine of 90 minus theta is going to be, these are going to be the exact same. So these two are going to be equal. Cosine and sine of 90 minus theta, that's going to be the same thing. Okay? And then tangent and tangent of 90 minus theta, let's see what that gives us, because that could be, that's probably going to be, oops, that's not what I wanted. So if we did say tangent of 70, that's going to be tangent of 90 minus 70. So tangent 70 and tangent 20, how do those relate to each other? So tangent 70 gives us 2.74, and then Tangent, there it is, tangent 20 is going to be 0.363970, blah, 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 blah. But the interesting thing about these is these are reciprocals of each other. If I take 1 and I divide it by this 0.3639, so we'll do second answer here, I'm going to get 2.747477, just like that there. And same thing if I were to take 1 and divide it by, if I were to take 1 divided by this 2.7474 here, second answer, then that's going to get me back to my 0.36397, blah, 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 blah. Okay? So it's just kind of trying to help you see that there is an actual relationship. Sine of B and cosine A, look, are B over C. Those are the same thing. Sine of A and cosine of B are also the same thing. So these are equal. Okay, and then these are just reciprocals of each other. You just flip them over, right? And that's what we showed on the calculator there. Okay. Anyway, that's all we have for 7A. If you have any further questions, please feel free to ask. Thanks.